We usually imagine the scientific revolution as a series of peaceful eureka moments. We picture Isaac Newton sitting in these very gardens at Woolsthorpe Manor, contemplating gravity in total rural silence. The archival reality is far more frantic. Newton was a man of deep obsessions and intense paranoia, spending years pacing through candlelit studies, fueled by a competitive drive that bordered on pathological. His breakthroughs were born from a friction between two opposing traits, a desperate craving for recognition and a paralyzing fear of public criticism. By the 1670s, the Royal Society of London had become the primary clearinghouse for intellectual prestige in England. The man managing that reputation was Robert Hooke, the Society's powerful and often dogmatic curator of experiments. Hooke controlled the vetting process. To enter the official scientific record, an author first had to survive Hooke's aggressive public style of peer review. This set a stage for a decades-long collision, a reclusive, fragile scholar forced to confront a public provocateur who thrived on finding flaws in other men's work. Newton began his career here, within the Gothic architecture of Trinity College, Cambridge, where he conducted his first major experiments with light in 1672. He sent the Royal Society a functional reflecting telescope, along with a paper arguing that white light is actually a mixture of distinct colored rays. He demonstrated that when light passes through a prism, it refracts and splits into a spectrum. Based on this, he claimed that light consists of tiny physical particles, or corpuscles, moving through space. Robert Hooke responded with a condescending public attack. He dismissed Newton's particle theory and questioned the young professor's experimental methodology. Newton was so wounded by the humiliation that he withdrew from the society entirely, hoarding his research and refusing to make his optical findings known to the world. This retreat effectively stalled the advancement of optics. Newton vowed to keep his theories secret as long as Hooke was alive to criticize them. By 1675, the two men were communicating only through a series of passive-aggressive private letters. In one exchange, Newton wrote the famous line, "If I have seen further, it is by standing on the shoulders of giants." While often read as a statement of modesty, many historians see it as a vicious insult. Hooke was famously short and hunchbacked, and Newton likely used the word giants to highlight his rival's physical appearance. This single sentence illustrates how closely their scientific discourse was entwined with personal animosity. The feud took an unexpected turn in 1679, when Hooke wrote to Newton seeking new material for the Royal Society's publications. Hooke proposed a hypothesis he couldn't prove, that the planets were kept in orbit by an attractive force that weakened with the square of the distance. This is the inverse square law. If a planet moves twice as far away from the Sun, the pull of gravity doesn't just halve, it drops to 1/4 of its previous strength. Newton realized he had the mathematical tools to prove Hooke right, but his spite kept him silent until 1684, when Edmund Halley arrived at Cambridge to ask him the same question. That visit pushed Newton to document his work, resulting in the Principia in 1687. He provided the geometric proof Hooke lacked, showing how gravity governed cometary orbits and tides. He claimed total ownership of the laws that still bear his name. Hooke had accidentally provoked his rival into codifying the mechanics of the entire solar system. As the Principia was presented to the Royal Society, Hooke immediately demanded public credit for the notion of the inverse square law. Newton was furious. He spent the following months systematically deleting almost every positive reference to Hooke from the final manuscript. Newton's reaction effectively drew a line between an armchair guess and a mathematical proof. He made it clear that in the new era of science, an idea was only as good as the math used to verify it. By refusing to share the spotlight, Newton helped transform science from a collection of hypotheses into a discipline rooted in rigorous calculation. Hooke died in 1703. Free from his critic, Newton immediately took over as president of the Royal Society. With Hooke gone, Newton finally published his work on light and color in 1704, ensuring his version of the truth became the standard. Today, the high altar and vaulted ceilings of Westminster Abbey serve as the final backdrop for Newton's legacy. Newton lies entombed here in marble, surrounded by the physical symbols of the universal laws he codified. It is a reminder that these discoveries didn't happen in a vacuum. Without a bitter enemy to challenge and provoke him, Newton's most significant ideas might have remained buried in the